Hey guys, welcome to your very first AP Bio review videos. So Mr. Morelli and I will be making a series of these to help you get ready for the exam on May 14th nope, that's not right, May 18th at 1 p.m. So today we're gonna do some stuff with energy. I like this is the one I can access. Notice the date says 2014. It's not going to totally match up with our units, but it does review all the concepts that we need, and then you'll have some more tools as well. So this actually is probably close to where we started the year. Okay, so I'm going to go fast because a lot of this is just to kind of trigger your memory for things that you did that you can pull out or rewatch Bozeman videos, stuff like that. Okay. All right, so we kind of started with chemistry. And so there were these kind of review words that we went through. So like an atom is the singular particle of an element that you can't break down anymore and have the same properties of the element. Proton, neutron, electron, you're familiar with. Remember that we compared covalent and ionic bonds. Covalent are strong, they're sharing. Ionic bonds is when one atom gives and one takes, and you have this attraction between these charged ions, which are atoms that have different numbers of electrons. A molecule then is something held together by usually covalent bonds like water. And then electronegativity is kind of how much an atom pulls on its electrons. So like we'll reference this with the slides coming up as well. So when you're looking at covalent bonds, again, we're talking about sharing electrons. And so water is a really good example. You have one oxygen atom, you have two hydrogen atoms, and they're sharing, right? But oxygen is much more electronegative than hydrogen. It's going to pull on those electrons more. It's an electron bully. And so you end up having this unequal partial charge. So overall, the water molecule has a charge of 0, but you have the oxygen end, which has a negative charge, and the hydrogen end, which has a positive charge. And so what you're going to end up with, which we're going to talk about a little bit, are hydrogen bonds between those water molecules, because that water molecule is kind of, it's like a magnet, like it's charged on either end. In a polar covalent bond, the electronegativities, oh goodness, that is a polar covalent bond. I just explained a polar covalent bond. That's water. The non-polar covalent would have similar electronegativities, and so it would not be charged. Water, again, is an example of a polar covalent bond because there's a charge on each end. Okay? I apologize. And so water itself can dissociate into hydronium, H+, and hydroxide, OH-. And that kind of takes us into acids and bases. Okay, so acids are anything that have a high H+ concentration. Bases are something that has a low H+ concentration or a high OH- concentration. I don't know where to put my picture here. There we go. Okay, so water can dissociate. It kind of goes back and forth. It doesn't really happen on its own that often. So when you're talking about pH, which you should not have to calculate, when you're talking about pH, you're looking at the concentration of hydrogen ions. How many H pluses are actually in something, right? So pH is low for an acid, high for a base, but an acid has an extremely high amount of H pluses, where a base is going to have a low amount of H pluses. So it's an inverse relationship when you're talking about the hydronium ions or the hydrogen ions. Our internal pH has to be relatively neutral, and so we have this blood buffer system that I'd like you guys to review. I don't have my stylus, so I can't write on the screen right now. But the idea of H2CO3. H2CO3 dissociates into HCO3- and H+, and how it can go back and forth depending on if we need more H pluses in the blood or less H pluses in the blood. Okay, so it's basically this acid-base pair that's a reversible reaction that can go either direction. So please review blood buffering system. Now that we know that water is a polar molecule, polar, right, not nonpolar, it's going to result in these hydrogen bonds that form between them. And so if you look here, the negative end of the red oxygen is attracted to the positive end of the white hydrogen, and you get these weak bonds that form between them that give water some really special properties. Okay. So properties of water that you should be familiar with: cohesion and adhesion. Cohesion is water sticking to itself. Adhesion is water sticking to other things. So both of those properties lead to some other kind of typical properties. Surface tension is one of them. If water sticks to itself, it's going to form this thin skin on the top that's kind of hard to break. Unless you're a human, you can break it really easily. But surface tension allows like water striders to walk and like stuff like that. There's also capillary action, which I don't know if it's on a future slide or not, that water is going to stick to the sides of like plant stems and then it sticks to each other. And so it kind of gets like sucked up a plant or a tree. High specific heat. So that's the idea that it takes a lot of energy to heat up water, but then water can hang on to its heat well. So that's the kind of the idea that as it warms up this spring, like the air might get warmer, like on this past weekend, this Sunday, it was super warm, but if you would go down by the lake, the water's still really cold there, okay? Because it takes a lot for water to heat up. But then in the fall, as we cool down, the lake doesn't like freeze on the first day that we hit 32 degrees. It hangs on to its heat longer, and it's going to take a while, if ever, to freeze. Okay, so that also is, if you look at the reason, it requires a lot of energy to break the hydrogen bonds in order to raise water's temperature. Like, that's a big reason why. Sorry, I have a tickle. Okay, some other ones. As water freezes, it expands. Excuse me. So what you end up with is ice being less dense than liquid water, which means that ice floats. And then water can dissolve things. So anything that's polar or ionic, water can surround and dissolve things. And that's where we're going to stop because I'm coughing.